questions 21 to 25 of the 2003 grade 10 AMC 10B. A bag contains 2 red beads and 2 green beads. You reach into the bag and pull out a bead, replacing it with a red bead regardless of the color you pull out. What is the probability that all beads in the bag are red after 3 such replacements? So, you have a bag, and then another bag, and then another bag. And our goal is to make all of the beads red, like that. After 3 replacements. Okay, so our initial situation in terms of how we start will vary. I think there's probably going to be the exact same start each time, right? 2 red and 2 green, but our order is going to change. So I'll just draw them out first. And we want our final condition to be all red for all 3 situations. And our initial condition or situation is always 2 red and 2 green. But how we replace them, that order will change. So the first one is that you're going to first pick a green, then you'll pick another green, and then you'll pick a red. The second situation is that you will pick a green, and then a red, and then a green. And the last one is you'll pick the red first, and then a green, like that. So let me explain all of these. And some of these will involve 3 steps, and some of them may not involve 3, may only involve 2. Because it says after 3 such replacements, but we might get to our final result quicker. So let's explain this as carefully as I can. You first take out a green. So I'm dealing with this one right here. You take out a green, and then you replace it with a red. That is the rules. So you took out the green, and you replaced it with a red. Still 1 green left. The next one you're going to take out is another green. So you take out the green, and you replace it with a red. Well, we've got all 4 red, but we got to keep going because we have 3 replacements. Now at this point you have no choice. There's only red to take out. You take out a red, replace it with a red, and there you go. Now we have to figure out what is the probability of this happening. Well, in the first one right here, what is the probability that you're going to get a green? Well, there's only 2 greens and there's 4 beads, so the probability is 2 out of 4 that you're going to choose a green initially. Then when you get here, what is the probability you're going to choose a green? Well, there's only 1 now out of the 4. And then when you get here, what's the probability that you're going to choose a red? Well, 1 out of 1. And you multiply those to get the full probability, and that looks like 2 over 16, which is 1 over 8. Okay, so that's the first probability. There you go. Now let's do the same kind of thing with the next scenario. The next scenario says that you initially take out a green. And I'll do that. Say I take out this one and I replace it with a red. Okay, and then that one's done. I'm going to take out a red this time. If I take out a red, that's fine. I have to replace it with a red, so nothing really changes. No problem. And then finally, I've got to take out the green, this guy right here, and replace it with the red. And I do, and I end up in that situation, which is what we want. Now I have to figure out the probability of this scenario. Well, for the initial green, the probability of getting a green is 2 out of 4. Next one here, the probability of getting a red is 3 out of 4. And finally, the probability of getting a green there is 1 out of 4. So you multiply these together and you get 6 over 64, and this in lowest terms is 3 over 32. Okay, so that is scenario number 2. Now let's move on to the last one. Hopefully by this point you're a pro. First one, you take out a red. You replace it with a red. Okay, nothing really changes there. Then you take out a green. You replace it with the red. So you get red, red, red like that, and the green. And then finally you take out the last green and replace it with the red. And you end up in this scenario. Now we have to figure out the probability. Probability of getting a red here is 2 out of 4. Probability of getting a green here is 2 out of 4. Probability of getting a green here is 1 out of 4. Multiply those to get the full probability, and you get 4 over 64, which is 1 over 16. All right, 1 over 16. There you go. So we have 1 over 8, 3 over 32, and 1 over 16. Okay, let's look at the answer choices. We've got 1 over 8 here. Do we have 3 over 32? No. And do we have 1 over 16? No. So what's the right answer? Is it A? Right? You tempted to choose A and move on. What do? Which one do I choose here? You have to add them. Add them. These 3 probabilities make up one entire question. They must be added. All right. So you have to add 1 over 8 plus 1, 3 over 32 plus 1 over 16. And when you do, you get a common denominator and you add them all up. You'll get 9 over 32. And therefore, the answer for number 21 is C. A clock chimes once at 30 minutes past each hour and chimes on the hour according to the hour. For example, at 1 p.m. there's 1 chime, and at noon and midnight there are 12 chimes. Starting at 11:15 on February 26, 2003, on what date will the 2003 chime occur? So let's make a table here. We've got February 26th, 11:15 a.m. And then the first chime occurs at 30 minutes past the hour, right? So that's 11:30 a.m. And I'll write number of chimes here. And then that's the first one. So first chime right there. And then we get into a scenario where we get to 12. 12 noon. So 12 p.m. And at that point you have 12 chimes. And then you have 12:30 p.m. and at 12:30 there will be 1 chime because there's 1 chime at 30 minutes past each hour. And then you get into 1 p.m. like that. 1 chime for 1 p.m. 1:30 p.m. you'll have 1 chime. 2 p.m. you'll have 2 chimes, right? 2:30 p.m. you'll have 1 chime, and then 3 p.m. you'll have 3 chimes because it's 3 o'clock, 3 chimes for 3 o'clock, and so on. So I will complete this table. So here is the big long table of all the chimes. So first let's count the chimes for the hours on the hour. We've got 1 p.m., 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then the 12 is all the way back there. So basically the number of chimes, if you were going to add them up, would basically be 1 plus 2 plus 3 all the way up till ... 12. And then the 1 chime that happens at 30 minutes past the hour, how many of those do we have? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those. Plus 12 times 1. Okay? So this looks like 12 times 13 over 2 plus 12. So 6 times 13, which is 78 plus 12, so 90. So this is half a day. So 90 for half a day. So for one full day, it'll be 180 chimes. All right. Now February 26th is a little bit different because we started at 11:15 a.m. here. So we got one extra chime. So February 26th, we had half a day plus one extra chime. So 90 plus 1. So we got 91 chimes on that day. All right. Now we want to figure out when will the 2003rd chime occur. Okay, no problem. Let's make a little calendar here. February 26th, 27th, 28th, 2003, right, was the date, but that was not a leap year, so I don't have to worry about February 29th. Then we get into March. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. I don't know how long I'm going to keep going here, but let's just do until the 15th and see what we get. So they want 2030 chimes, right? So on February 26th, we had 91 chimes. That's what we figured out. And then we'll have 180 on each of these full days, like that. And they're saying, where do you, on what day, get the 2003rd chime like that? Okay, no problem. We can do that mathematically. 2003. First, let's subtract this 91. All right? And that will give you 1912. Now, you take 1912 and say, okay, this is got to be divided by 180, right? Because every day you're going to be getting 180 chimes. So that will give me the number of days. If I do this, it's about 10.62 approximately. So that means 10 days have to go by. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in 10 days, it'll be 1,800 chimes, right? And then I've got an additional, 112 chimes. And those 112 chimes occur here on March 9th. Right? So I hope that makes sense. So March 9th is when the 2003rd chime occurs, and therefore that would mean 22 is B. A regular octagon has an area of 1 square unit. What is the area of the rectangle? ABEF. So this entire shape has an area of 1. They've told you that in the question. Area total is 1. And we want to figure out the area of this rectangle right here, ABEF. So I'll have to draw little parallels there. That guy. All right, so we will have to do some labeling first. So I will call X the side length of this octagon, like that. They're all X's, right? Because it's a regular octagon, or that's why all the sides are the same. That's why it's called regular. Now, I need to figure out a lot more than this, but some of these are kind of intuitive. That's X, that's X, that is X, that's X. But these sides are definitely going to be needed. That one there and this one right there. So how do I get that? Well, one thing is for sure that you definitely will find helpful is the sum of all the angles in an octagon, or what? Now, if you don't know the answer, that's actually not a problem because you can just figure this out. You definitely know that the sum of the angles of a triangle are 180, right? And how many triangles are there in an octagon? There's 6. So 6 times 180, which is 1080, is the sum of the angles of all the interior angles, all of those guys. So each individual angle will be what? 1080 divided by how many individual angles did I draw there? 1, 2, 3, 4, 5, 6, 7, 8. And there you go. Each individual angle will be divided 1080 divided by 8. And if you do that, you get 135. So that means that each of these guys is 135. Okay? Now notice this is a right angle right there, the way I drew it. So if this whole thing is 135, then this must be 135 minus 90, which is 45. And in a very similar way, if this whole thing is 135 and this is a right angle, then this must be 45. All right? So that triangle, I'll draw it a little bit bigger here so that you can kind of see. That triangle that I drew in has got the following parameters. This is x, this is 45 degrees, this is 45 degrees, and this is a right triangle. And therefore, we can now calculate these sides. I will label it, say, y. And therefore, y squared plus y squared is equal to x squared. 2y squared is equal to x squared. Y squared is equal to x squared over 2, and therefore y is equal to x over root 2. Okay? And at this point, I think we have it all. We just have to put it all together now. Our total area, T area, in this diagram, we will have 4 of these little triangles, these guys right here. There's 4 of those. All right? And those are all exactly the same in terms of their area. So 4 of those, each of them is 1/2 base times height. The base is y, which is x over root 2, and the height is the same. That takes care of those little guys. Now we've got 4 of these rectangles, which are exactly all the same. So we got 4 of those. So 4 times length times width. The length is x, and the width is x over root 2. And then finally, we've got one final big one in the middle, that square basically. And of course, the area of that is just x squared. And then T area, we give you in the question, is equal to 1. And there you go. This equation is going to help you solve for x. All right, so let's do the math here. 1 is equal to, we've got x squared 2 over 2. So that's just x squared. This one now becomes x squared and then 4 over root 2. Like that. And this is the final one is just x squared. So the good news is you can factor out an x squared, and that will leave you with 1 plus 4 over root 2 plus 1. This becomes 1 is equal to x squared, 2 plus 4 over root 2, like that. And therefore we can now get a common denominator. 2 root 2 over root 2 plus 4 over root 2, like that. And this looks like x squared is 4 plus 2 root 2 all over root 2. You can rationalize the denominator once more, and this will give you 4 root 2 plus 2 times 2, which is 4, all over 2. And finally, this looks like x squared is 2 root 2 plus 2, and therefore finally x squared is 1 over 2 plus 2 root 2. Okay, there we go. Now finally we get to figuring out our ABEF, this guy right here. ABEF, this is what they want us to figure out. So ABEF is length times width, x times looks like this was y, which is x over root 2, and this is just x, and this was also y, x over root 2. So we've got x over root 2 plus x over root 2, like that. Move this up, and here we go. So this becomes x times 2x over root 2 plus x, and multiply this out, and we get 2x squared over root 2 plus x squared. Factor out the x squared, and that will just give you 2 over root 2 plus 1, like that. I think we can add those. 2 over root 2 plus root 2 over root 2, like that, common denominator. So we got 2 plus root 2 over root 2. Multiply top and bottom by root 2 to rationalize the denominator, and you'll get 2 root 2 plus 2 all over root 2. Sorry, all over 2. And finally, this gives you root 2 plus 1. There you go. And then x squared is right here. So that becomes 1 over 2 plus 2 root 2 plus 1, like that. And on the denominator, if you factor out a 2, you'll get 1 plus root 2. And look at that. The numerator and the denominator have things that can cancel. So all you're left with is just 1 over 2. So that is the answer. 1/2 is the area of ABEF. Area of rectangle ABEF is 1/2. So therefore the answer to number 23 is D. The first 4 terms in an arithmetic sequence are x plus y, x minus y, x, y, and x over y. In that order. What is the 5th term? So in arithmetic sequences are of the form a plus k, a plus 2k, a plus 3k, a plus 4k, and so on, right? So they've told you that this is x plus y, this is x minus y, this is x times y, and this is x over y. And they want you to figure out that 5th term. All right. Well, the first thing is I'm going to concentrate on what is k. What is my difference every time? K can be easily figured out. A minus k minus a. You take the second term, and from it you subtract the first term, and that just leaves you with k. Now, if I do that in terms of x and y's, what do I get? X minus y for my second term. My first term is x plus y. So this gives me x minus y minus x minus y, which is just minus 2y. So therefore, my k is minus 2y. So that's my first piece of information. And now I'll concentrate on getting a. So several ways to proceed here. So if we proceed with that, we can go back and look at these terms a little bit more carefully. A plus k, a plus 2k, a plus 3k, and a plus 4k, right? The first one is just a, and we are told that it's x plus y. Second one is a plus k, and we are told it's x minus y. Now, to get the next one, we would basically take this one and add k. So you're just basically taking this and adding k, correct? So you would take x minus y and add k to it, and k is minus 2y. All right? You see how that went there? So this is basically x minus 3y. Very similarly, to get a plus 3k, you're taking this guy and adding a k. So you're taking this guy and adding a k, and a k is basically minus 2y. So this becomes x minus 5y. And very similarly, to get that term, you take this term and you add k. And this term is, of course, x minus 5y plus k. K is minus 2y. And there you go, x minus 7y. So these are our values in terms of x and y. We have x plus y, x minus 3y, x minus 5y, and x minus 7y. Okay? So let's move this up. Now we are given some very important clues by the question, right? We are told that our third term is xy and our fourth term is x over y. So our third term is xy and our fourth term is x over y. So we can use that to equate these. That means that x minus 3y is equal to xy and x minus 5y is equal to x over y. All right, so with this guy here, I'm going to isolate for one variable. I'll bring everything over like that, put the 3y on the other side, and if I factor out an x, I'll get 1 minus y is equal to 3y. So x therefore is 3y over 1 minus y. And in a very similar way, I'll do the same thing over here. I'll isolate for one variable. We can, in any way you want, we can cross multiply first. Xy minus 5y squared is equal to x. And then xy minus x is equal to 5y squared. And then xy minus 1 is equal to 5y squared, like that. And therefore x is equal to 5y squared over y minus 1. And there you have it. We've got two values for x. We can set them equal to each other. 3y 1 minus y is equal to 5y squared, y minus 1. We can make the denominators be exactly the same if we multiply top and bottom by -1. And therefore, since the denominators are the same, the numerators must be the same. Divide both sides by y and you get minus 3 is equal to 5y. And finally, y is equal to minus 3 over 5. If you substitute this back into any of these, you'll get x 3 times minus 3 over 5 over 1 minus 3 over 5, like that. And this will give you minus 9 over 5 over 8 over 5. Invert and multiply minus 9 over 5 times 5 over 8. And this is equal to minus 9 over 8. So there you go. You've got x and y. And in our final step, we just have to figure out this guy right here. X minus 7y, because that is the fifth term. X minus 7y. So x is minus 9 over 8. Minus 7 times y, which is minus 3 over 5. And therefore this is minus 9 over 8 plus 21 over 5. Cross multiply, or rather get a common denominator, I should say. You got minus 45 plus 168 all over a denominator of 40. And this is 123 over 40. And there you go. That's the fifth term right there. 123 over 40. And therefore, this would be 24 is E. How many distinct four-digit numbers are divisible by 3 and have 23 as their last two digits? So, four-digit number, 1, 2, 3, 4. So it's got to be anywhere between 1,000 and 9999 inclusive. This is our range, I guess. So the numbers have to be divisible by 3 and they have to end in 23. So 1023, 1123. I'm just writing the numbers that end in 23. And I'll just do this for the range 1000 to 1999, like that. So 423, 523, 623, 723, 823, 923. There you go. Now, we just have to do this once. We have to figure out the other part of the criteria. We fulfilled our first criteria, but they also have to be divisible by 3. So let's see. If it's divisible by 3, this one is. This one is no. This one is no. This one is divisible by 3. Yes, it's 441. This one is not. This one is not. This one divisible by 3. Yes, it's 541. This one no. This one no. And this one is divisible by 3. It is 641. Like that. So basically, it looks like if you keep adding 300 to each of these numbers, it will fulfill both of our criteria. You see what happened there? If I keep adding 300 all the way up to the very end, and the very end will be 9723, because that divided by 3 is 3241. Okay? So that basically are all of our numbers that fit both criteria. They have 23 as the last two digits, and they're divisible by 3. Now we have to count how many of there. Well, we got 10, 2, 3, 13, 2, 3, 16, 2, 3, 19, 2, 3, all the way up to the last one, 9, 7, 2, 3. So how many of these? Well, it's not as difficult as you think, because 10, 2, 3 was just 3, 4, 1 times 3, correct? 13, 2, 3 was 4, 4, 1 times 3. 16, 2, 3 was 5, 4, 1 times 3. I hope you're seeing a pattern here. 1923 was 6, 4, 1 times 3, and so on, all the way up to 32, 4, 1 times 3. So what was the pattern? We've got 3, 4, 5, 6. It'll be 7, 4, 7, 4, 1, 8, 4, 1, like that, all the way up to 32, 4, 1. So basically all the numbers from 3 to 32, except for 1 and 32. Those are not there. So how many are those? Well, that's 30. So 30 is the answer to this question. Number 25 is B.